Applications of non-destructive techniques in the study of a Caribbean historic timber house. The authors of this presentation are Virginia Flores, Esteban Prieto, Gabriela Fernández, and Raquel Carreras. In a historic building, one of the most susceptible materials to be replaced by a new one is wood, regardless of whether it's in good or bad condition, due to a lack of knowledge of its characteristics and by being carried away only by physical appearance. With the systematic elimination of wood in a few years, it will be impossible to make a moderately correct and serious reading of our historic architectures. However, wooden structures after several centuries have proven to be resistant and durable, except for specific moisture or xylophagous problems. It is appropriate to use non-destructive testing because we can evaluate the properties of a material and determine the state of preservation or the degree of the integrity of the materials without causing any damage to cultural heritage. Case study. The town of Sanchez is in the province of Samana, Dominican Republic. In the beginning, it was a small fishing village known as Las Cañitas. In 1879, it became a very prosperous city, as a result of the construction of a port where many transatlantic ships arrived with imported goods, people, and many technological advances that were marketed and distributed throughout the island. Bodden-Leroux House. The Bodden-Leroux family built their house at the end of the 19th century. Is a catalog house from the USA. The house is a simple layout with ornate wooden details, often called farmhouse, national styles, or American four squares. This house was built on a sloping terrain, so it rose on wooden piles, which makes it look bigger. It's a simple farmhouse with rectangular plan, divided into rooms that communicate by a central corridor, and has a perimeter gallery where all the doors and windows open. The whole structure is made of wood, with horizontal sliding plank pinewood boards of 13.97 centimeters wide. The floor of the house is also made of pinewood boards. The metal roof is hipped with four gabled dormered windows. The house has been modified and expanded. However, its appearance has not changed much. It is currently abandoned. Environment conditions. Sanchez, Samana. The Dominican Republic is in the Caribbean, located in the tropical zone of the Northern Hemisphere, at latitude 18.73 and longitude -70.16. The geographic coordinates using format degrees and decimal minutes is latitude 18 degrees north and longitude 70 degrees west. The average annual minimum temperature is 22.13 Celsius and maximum is 31.18 Celsius. Average precipitation is 172.09 millimeters. Average relative humidity is 80%. Average wind speed is 2.2. And average monthly hours of sunshine over the last year is 9 hours. Materials and method. Visual inspections. The visual inspection provides a preliminary indication of the condition of the wood and the degree of the damage. This is the simplest way to evaluate and assess a building, and a very important component of any analysis. Includes naked eye observations and can provide information about the stages of deterioration. Ultrasound. To detect and quantify wood internal decay was used the Rintec R-Bottom, an impulse tomography unit that enables an inside view of condition of timbers and trees. These methods generate ultra-high frequency sound waves through the material, and when a discontinuity such as a crack or any other imperfection is encountered, part of the sonic energy is reflected. It is then measured and displayed on a screen. A series of sensors are placed around the structural elements and produce an image. The image was used to quantify the proportions of undamaged and damaged woods. With species-specific algorithms and optional color schemes allow for detailed analysis of decay data. Optical. A 1 centimeter cubic block was extracted to be processed and identified by the comparative wood anatomy method. Cross-sectional observations were made at the digital microscope and photographed. Thin sheets of radial sections were manually extracted to be observed by an optical microscope and then photographed. Infrared camera FLIR system model T420 was used for infrared thermography. The IRT offers a thermal image with different temperatures that is interpreted as moisture area, and with that can detect levels of moisture content in wood. This dynamic difference provides information about location and shape of defects. Electromagnetic was used an electronically controlled Rintec resistograph, a resistant drill for detecting decaying woods. The equipment used DECOM software to analyze the data and produce credible charts that properly reflect actual wood conditions. The drill direction was radial to the grain, and the drillings were performed relative to the tangential direction at 90 degrees angle. Different parts of the structures were sampled, and each sample was drilled 3 times to obtain a mean drill of resistances of these measurements were averaged to form the average mean drill resistance. The sample are the pile P1, P2, and P3, column C1, C2, and C3, beam B1, B2, and B3, and joist J1, J2, and J3. The piles are circular, the columns are square, and the beams and joists are rectangular. Results. Visual inspection. The visual inspection indicated that the siding plank and the veranda presents area of deterioration. Only 20% of the rafter beam, joist, brace, and pile presents deterioration or damage. The 50% of the post columns present damage. 30% of the floor presents large area of deterioration and 50% presence of damage. The 65% of the roof presents damage. The 80% of the doors and windows presents damage and deterioration. In general, visually, the 80% of the house presents damage. Results. Ultrasound. The ultrasonic testing enabled detection of a deep and extremely small flaws within the material. In the ultrasonic diagrams, you can observe that all the piles are in very good conditions. P1. The columns and the veranda, C2, has some crack and deterioration due to humidity. A beam, B1, in the roof has deteriorated and the joist present some deterioration. Even though some columns look dry when the tomography is carried out, it could be determined that they're in good conditions inside. The same thing happened with the beams. The same thing happened with the elements that conform the frame of the building structure. Results. Optical. It was identified that all the pieces are amassé o cambia. The beams, joints, decorative elements, some boards, and the wood frame are Pinus strobus, white pine, northern white pine. The boards in the house extension and the repair woods are pine, southern yellow pine. This indicates that the house was brought from the north of the United States, which was very common until the late 19th century. The piles are made of local wood. This was also very common, as the level of the house was resolved on site. The extension of the house and the repairs are made in the middle of the 20th century, and at the time, the wood that came to the country came from Louisiana, so it's not strange that it is southern pine. Results. Thermography. The thermography indicates that the thermal conductivity of wood is relatively low due to its porosity. As the humidity of the wood increases, so does its thermal conductivity. As the temperature of the wood drops, its strength increases. Results. Electromagnetic. The measurements were taken on January 9, 2019, between 10:39 to 2:39. The average temperature was 27.69 Celsius, with a maximum of 30.8 Celsius and a minimum of 22.5 Celsius. The relative humidity average was 53.12%, with maximum 64.9 and minimum 41. The equilibrium moisture content of the wood in these environmental conditions is between 9 through 9.6%. All the samples had a higher than normal level of humidity because the metal cover in the house is broken, allowing water to pass through when it rains. In some cases, such are verandas, the wood is exposed to climatic conditions. All mechanical properties showed a decrease upon increasing the moisture content from above 12%. The average of the mean drill resistance of the samples indicated that the density of the pile are higher than the normal value. The C1 and C2 are within the normal range, but C3 is higher. The density of the sample of the beams and joists are higher. Result: electromagnetic. In some columns, the effect of the moisture content could be observed by finding little resistance with the drill of the resistograph. The permanence of moisture in the wood could be confirmed visually by the presence of fungi. This is important to know because it influences the mechanical properties of the wood. Conclusion: through visual inspection, it was determined that in general the structure of the house is in good condition. The main injuries are in the enclosures, floors, ceilings, and veranda, which shows an advanced deterioration, mainly caused by moisture. Also, improper repair, loose joint and connection, missing wood, and color change are some of the damage that can be appreciated by visual inspection. Ultrasonic tomography, coupled with image analysis and the resistograph, provide an efficient, non-invasive approach to evaluate the condition of the internal decay of the timber and the structure. In general, the yard bottom indicated that some structural elements had internal lesions. Although they were not visually appreciated, gaps and soft areas were detected in some columns, while in others can be observed the good state in which are weak. The resistograph affirmed that data obtained with the ultrasound and indicated the resistance of the samples. The thermographic inspection allowed to note the presence of moistures on the pieces, detect insects and anomalies. The moisture level was tested with thermos hydrometer, and as the wood dries, its strengthened properties improve significantly when the moisture contents fall below the saturation point of the grain. The wood begins to suffer damage if its moisture content remains above 20% for long periods of time. The heat capacity of wood depends on its density, moisture content, temperature, and direction of the grain. In conclusion, some of the non-destructive testing can be used for investigation of historical structures. The benefit to use the non-destructive testing is that it can be applied in situ. It does not require to take big samples to destroy and to obtain such information. In addition, they are the most appropriate tools for the evaluation of external and internal wood structures, and for assessing and analyzing the quantity of materials in cultural heritage. Acknowledgement. This research is part of the project Ensayos no destructivos y pseudo no destructivos para determinar el estado de los elementos de madera en edificaciones históricas y soluciones para evitar los procesos de degradación, funded by the Ministry of Higher Education's Science and Technology. Thank you for your attention and interest. Gracias por su atención e interés. Grazie per le attenzione e l'interesse.